Deborah for her talk. I love Deborah in the community because Deborah, you're always like a very sort of stable, steady, supportive presence. And, obviously you've done so much work in terms of educating the community. And, that's just been a really, really awesome thing that we all love and appreciate. Every time we talk about Angular, it's like, oh yeah, Deborah's the best teacher ever. So yes.
Thank you.
Yes, thank you so much for doing that, and all the work you've done. I mean, you were the first person that really taught me. I think you taught me forms.
Yeah, I remember.
Yeah, and so back in those days, and the fact that you're so willing to reach out to the community and help community members is really what makes the Angular community so special and awesome. It's what I found so special about the Angular community. So thank you for doing that. Thank you for being here.
Sure.
Now, next up, we're going to go ahead and Deborah, I've added you to the screen and you can get started anytime you like.
Okay. RxJS action and data streams, a love story. How do you react to actions in your Angular applications? Would you consider using RxJS streams? What do I actually mean by actions in this context? Well, basically any user interaction with the application, any actions or events that occur within the application, like clicking a button, user typing in text into a text box, and so on. My name is Deborah Kurata. I'm a software developer and Pluralsight author. And I just want to take a moment during this incredible and stressful time. May you each be the light in your family, in your group of friends, and in your community. Let's get started. So this session is on reacting to actions with RxJS using data and action streams. So we probably should start off by defining what those are. You've probably worked with data streams, though you might not have actually called it that. A data stream is basically the stream that is created when you issue an HTTP GET request. So if you've done any Angular of any amount, you've probably issued an HTTP GET request. And when you do, it automatically creates an observable for you and provides that to you. And that's what I'm calling a data stream. Now you notice that I'm representing it on a marble diagram where the marble is the response from the HTTP GET request, which is an array of products. I only have the name in there, but you can imagine it's got all the data in there. And then the vertical line to the right of it is a marker that indicates that it's complete. The interesting thing about data streams is that they are all one and done. What I mean by that is they emit just one time and then they complete, and that's it. So one and done. Emit the one response and complete. So if you request one product, it returns that one product and the response completes. If you want, a select star, all of the products from the endpoint, you still get all of them as one emission in an array, which is what we have here. Action streams, on the other hand, are more alive, hence the word action there. They are full of action and life. Action streams basically depict any of the actions in the application. So the user clicks a button, and every single time they click that button, you're going to get an emission in that stream. Or the user moves the mouse, and every single time they move the mouse, you're going to get an emission on in the stream. Or in our example, the user clicks on a product. So they clicked on the product with an ID of 42, that is emitted into the stream, that 42. They clicked on the product with an ID of 15, that ID of 15 is emitted into the stream. So that's our action stream. To help us better picture this, we can kind of think through this sample application. So here we've got our list of products on the left, and we've got our product detail there on the right. So our data stream is going to be bound to our product list, and it shows all of our products. Our action, then, we will emit an action every time a user clicks one of those products. We'll react to the action in the detail page and display the detail. So how do we implement this? Let's start with the data stream. Angular is all about TypeScript. TypeScript is all about type safety. So the first thing that we always do is define a structure of our data so that we can strongly type it. So here I've got my interface for my product entity, all of its different properties here. Now, our classic pattern for retrieving data is to create a service. Here is my product service. And in that service, we have a method, getProducts, and it returns our observable of product array. When a component or another piece of the application subscribes to the result of this method call, it will issue the HTTP GET request. So it issues the request. At some later point in time, we receive the HTTP response, and Angular automatically takes that response and maps it into the structure that we specified in the generic parameter of our GET. So our HTTP GET generic parameter product array. So it's going to map that response into a product array and emit it into the stream. It will then show up on our UI or wherever we've bound it. But let's think for a moment, if we took this exact same code, this exact same HTTP GET, and instead defined it as a variable. We had it declared instead of a procedure. So here is our declarative pattern for reactive data. So it's the exact same code, but instead of having it inside a method call, we're just going to assign it to a variable. So we've got our products dollar stream, and the convention is to append a $sign when we're going to be working with a variable that is going to be an observable. That kind of helps us easily recognize when products would be the product array and products dollar would be the observable of the array. So that then basically is our data stream. So we've got it declared here. Well, what does that do then for the component? We then also declare a variable there, again, products dollar, and we set it equal to the value from the service. And because we're working with observable streams, we can define a pipeline of actions that we want to have occur once we receive an emission. What about the UI then? Well, because we are defining an observable, we use the async pipe. So products dollar pipe async as products. And what the async pipe does for us is automatically subscribes and unsubscribes, so we don't have to deal with any of that mess. We don't have to do take while or take until or remember which one we were supposed to use or any of that. We can instead just async pipe it. It will subscribe, it will unsubscribe. And when an item is emitted, it's emitted into the variable we've defined in the as clause. So when our products dollar stream emits that array of products, it will emit it into the products variable, and we can then use that within the context there in the template. Okay, now you might be wondering why? Why would you want to do this? What are some benefits of using this declarative approach for your data stream? So first of all, this is our data stream. Here's our HTTP GET, and there's the result. So question then, why? Why do we want to do this? One thing that gives us is improved change detection. When we're binding in the template using an async pipe, we can use the on-push change detection. which more clearly defines when to do change detection instead of the default change detection, which might occur too often. So it can improve your performance by doing change detection only really when it needs to. Another reason is we can leverage the RxJS operators. There are well over 100 RxJS operators that we can leverage. So by declaring these streams, we can actually leverage those. We can compose streams. Frequently, our user interface for any real application has more than one set of data on it. We might have multiple HTTP endpoints that we have to get data from and combine that before we display it in the UI. That's really easy to do with our streams. And lastly, the one that we're going to be focusing on in this session is you can very easily react to user actions. So instead of having to write procedures that when this happens, then do this, it all just works like magic. All right, so that's our data stream. What about our action stream? How do we go ahead and implement that? Well, as I mentioned, when we don't ever create our data streams. They're created for us automatically when we issue an HTTP GET request. But our action streams, we have to create those ourselves. We do that with a subject or behavior subject. A subject and behavior subject are a special type of observable that are multicast. A subject and behavior subject behaves as an observer, meaning it has next, error, and complete methods on it. Next will emit an item into the stream, error errors out the stream, completes the stream. But it also behaves as an observable, so we can actually access the observable part of that stream. Notice the pattern that we're using here. We use private to declare our subject, and frequently I'll do that within a service. What that does is it ensures that only the service can work with that subject. Only the service can emit items into the stream, can error out the stream, can complete the stream. That ensures that accidentally some other external component or other service can't mess with our stream. Then we define a public property, product selected action $, because again, it's an observable that represents kind of the read-only part of our observable stream. And that's the part that our components or other services can subscribe to. Okay, what is the difference then between a subject and a behavior subject? Well, a subject just emits. The user clicked, the user clicked, the user clicked. A behavior subject, on the other hand, retains the last value. So why is that important? Well, if you have any subscribers coming late to the game, with a subject, they will only get the next emitted value. With a behavior subject, they will get the last emitted value and then each next emitted value. Where that's important, we'll see in a few moments. A behavior subject then, since it always has this concept of giving you a value when you subscribe, it has a default value, which we define in its constructor argument. In my case, I've got a 1 in there as an example. Okay. How do we then emit an action? Well, we would define a method. And again, if my subject is encapsulated within a service, I would have this method publicly available in a service, and anywhere in the application that wants to say, hey, the user picked another product, we emit that product ID into the stream using the next method. So that's our action stream. The user clicks on the product with an ID of 42. The action in the UI, it calls this change selected product. It emits that ID into the stream. The user clicks on a different product with an ID of 15. It again calls change selected product and emits 15 into the stream. So we've defined our data stream that defines our list of products there on the left. We've defined actions so that we know which product that the user clicked. Now what we need to look at is how we react to those changes. How does the product detail actually react to the fact that it received notification that the user clicked on product 42? How does it deal with that? If it's only getting the 42, how is it getting the rest of the data? It needs to go into the array and look it up. So how do we take care of that code? That's where our data stream meets our action stream. We do that with the combine latest. So here we've defined another stream, selected product dollar, and we're calling combine latest. So combine latest is an RxJS creation function that combines multiple streams into a new stream. It uses the latest emitted values of each of its input streams, and we'll talk more about that in a second. One of the cool things is, excuse me, that it will wait for each input stream to emit at least once before it starts emitting. Now, one of the common questions that I get is, I need to do X, but I need it to wait before I can do X. Doing something like combine latest is a great way to deal with that because it will wait for your products to come in. Here I'm combining our product stream, that's our data stream, with our product selected action stream, which is our, excuse me, which is our action stream. So we don't want this to execute until we have the products. Luckily for us, it will just wait automatically. It'll wait till it receives the products. It will continue to wait until it receives that first emission from our action stream. And this is where it's important whether we use a behavior subject or a subject, because if we use a subject, this will wait until the first time the user picks something and causes that action to happen. If we use a behavior subject, the second stream will emit right away, and then it just waits for the products to come back from the backend server. When it combines these streams, when it receives the emission from the data stream and it receives an emission from the action stream, it then emits an array of values in order, one for each input stream. Now, those words are difficult to parse, so I put it on as a picture here. So what combine latest emits is an array, so that's an array, where the first element is the emission from the first stream, which is our data stream, so that's our array of products. The second element of the array is the emitted value from the second stream, which is our selected product ID. So that's what combine latest emits for us. Okay, so what are we going to do with these combined streams? Well, we're going to map them. We want to have some kind of transformation. Basically, what we want to do is we want to look up the selected product ID in that list of products so we can return the selected product as the one product that the user selected. But what is that weird syntax? What does that do? That's basically array destructuring. If this was just an array variable, A in my little example there, then we would have to actually reference our elements using array syntax. So you would have A sub 0, A sub 1, and somehow you'd need to remember that A0 represented the array of products and A1 represented the selected product ID, and that's kind of confusing. So what array destructuring lets you do is give a name to each array element, a variable name. So our first array element, we're going to call products. Our second array element, we're going to call selected product ID, so we can more easily work with those without having to use the array syntax. Then inside our map, inside our transformation here, what we're going to do is use the find method on the products that it provided to us and look up the one that matched that particular ID, and that is what is emitted from our selected product dollar stream. And if the detail page subscribed to the selected product dollar in its template, bang, it will immediately show that ID in the page, that product in the page. Very cool stuff. All right, so bang, there it is. The other really cool thing about all of this is it will re-execute the pipeline on every emission. So our data stream, as we said, emits only once. It's never going to emit again. It just gives us the data and then completes. But our data stream, if the user picked one of the products, what it will do is combine latest with our data stream and our action stream, and it emits this array with our products and the 42. And if the user then picks a different one, it re-executes its pipeline. The combine latest will re-execute with the last emitted value from each stream. Well, our data stream is only going to emit one, so we'll just keep getting that every time. And that's what we want, right? We want that list so we can pull off the one that they picked. Seems like magic. So it will re-execute this pipeline, re-find it, and automatically display the other one. So you don't have to be writing procedural code. If this happens, then this, then do that. This will just automatically, every time a new item is emitted, it will automatically re-emit the correct product to display on the detail page. All right, so our steps: define a data stream. Again, we don't have to actually create the stream. We just define it by issuing an HTTP GET request, create an action stream. Those we do need to create with a subject or behavior subject. We emit a value every time an action occurs, and we combine the action and data streams. With that, let's look at another example. Here's one that's a little bit more complex. It's got more stuff going on, and you can imagine what the code would be like to try to respond to all of these things. The user can type in a filter by, they can use previous and next to go through the pages. They can show the results 2 per page, 3 per page, 5 per page. And again, I only have a small amount of data in my sample app. In a real app, it might be 5, 10, and 25, or 5, 25 and 50, doesn't matter what the numbers are there per page. But the idea is that the user can change that, they can change what page they're on, they can change their filter, and you want the screen to adjust automatically whenever that happens. So how do we implement that? Well, the imperative technique would be we would have some kind of method, right? And we'd pass it the list of products and pass it the filter by string, and it would return the filtered list of products, and that would give us the filter part. Or if we were going to have it done on the back end, you know, because if you have thousands and thousands of products, you're not going to bring them all down and filter them on the client. You would want to issue an HTTP GET and pass the filter there and get back the filtered set of products. So how are we going to do this when we're using a declarative approach? Because we can't pass things in. That's one of the most common questions that I get when talking about this declarative approach. If you're declaring a variable, you can't pass things to it. So how do you deal with that? Our data stream plus our action stream. So here our data stream is this.allProducts $, so that's all of our products. Then we're defining a subject, and we're going to use a behavior subject here. I'll talk about why in a moment. And so we have our I should have the private keyword on there, private filter subject, and our filter action as observable. And what we're going to do is use combine latest to pass in data. What that does is it gives us access to both sets of information. So it will give us our data stream, and it will give us our filtered action. Now here is a prime example of when you would want to use behavior subject, because if we are going to bind to filtered products, if we want the user to be able to see that list of product immediately when the page comes up before they've necessarily typed a filter subject, we need that filter action to emit right away. Otherwise, filtered products won't emit. So that's why we use a behavior subject and just pass it an empty filter action. Our map then again uses array destructuring. We'll perform the filtering and display the entire list because our filter is an empty string. Okay, so that's the filter part. So that'll take care of filtering, but what about all that other stuff that's on there? We can create action streams for those as well. So here's the page size. We've got page size subject. That's also a behavior subject set to 5. and its action. And again, we're going to define a combined latest and pass all of these in. Now notice that first stream there, filtered products. That's our stream from here. That's our filtered product stream. So one of the other nice things about doing this way is that we can combine these streams in different ways and in separate steps. So we don't have to have one massive combined latest with all the complexity of the code performing the filter and doing the page size, because we can take that one stream and combine it again with some more. So here we're combining it with what current page that we're on and the page size action, whether it's 5 per page, 10 per page, 15 per page, whatever it is. And then we are mapping that using slice to display the appropriate set of information. Okay. So this is the different set of code that we would use if we wanted to do this on the server. So this is the technique that we would use if we download all the data first, because we're going to work with a small enough set of data that makes sense. Otherwise, we pass parameters in to our HTTP GET. And again, this is how we're passing parameters by using combined latest. So notice we don't have a data stream in this case because we're going to be passing all of this to the backend server. So we have our action, we have our current page, we have our page size, and that's how we're passing the data. Then we can do our switch map, and we've got our array destructuring, so we can name those things nice variables, and we define our parameters for our HTTP GET. Okay, everything that we just saw here regarding these streams for paging and such, this all came from Aaron Frost, so I want to thank him for showing me these techniques. I just want to give him kudos for showing this. The first time I saw it was in a presentation he did in an Angular meetup in Colorado. That was really great. So I stole part of his example and wanted to include it in this talk to really give you the sense for how to pass data into these things. All right, so data stream and action stream. So our data stream, like for example, our products, one and done. We have an action stream, which was for our current page. We have another action stream for our page size. We have another one for our filter, but I only had room for 2 here. You can combine them. It will emit the most recent value from each stream once each stream emits. If the user then goes next to go to the next page, it re-emits the most recent emission from each stream. So our set of products are 2 and are 5. And if the user then changes to a page size of 10, again, it emits the most recent value, our array, the 2 and the 10. Bottom line, data stream plus action stream is love. Here are some links. This is my GitHub and my Twitter. So I have a sample application with the pagination in that GitHub repo. And thank you all very much.
Thank you so much, Deborah. There's tons of questions in the chat. So I don't know. I mean, we have a few minutes if you want to answer any.
Well, where am I looking for them?
On the right-hand side, you'll see comments, and you can just click on comments.
I'm not sure I have this open. Let me see here.
It's actually in the in StreamYard. So on the right-hand side, you'll see comments.
Oh, live comments. There we go. I was looking at the wrong tab. All right. So yes, Aaron Frost does rock. Hi, Aaron. Let's see. Love that pattern, combine latest. Awesome presentation. Thank you so much. I'm looking for questions.
Well, I guess we don't have that many questions. I thought we did. But I guess the question I saw was with a declarative approach, how do you prevent your code from getting cluttered? But that might be a longer one.
How do you keep your code from getting cluttered? That's a good question. Well, because of the way that you can merge these streams any way that you want, you can definitely put them in different services. So you don't need to have them all in the same service because the streams themselves are defined as public properties. So you could have a service that just knows how to deal with your pagination, for example, and another service that knows how to deal with your product data, assuming that you're doing your pagination on the client side. So you can break these up because you're dealing with those streams in a declarative way, and because they're public and services, you can organize them as into smaller segments and still merge them all together. So that makes it really easy to keep it from getting all clogged up and messy, because I don't like messy code either. Did you see any other questions in here?
I think
Love that pattern.
I think that was the only one.
Okay.
But thank you everybody
Cool.
for
Somebody asked for the last slide again. This
yeah,
one.
yes. I think thank you so much, Deborah, for joining us. And you can find Deborah on Twitter at Deborah Kurata, which is on this slide right here. You're always like willing to chat and help people out. So feel free to reach out there, and Deborah will let you go. And again, thank you so much for joining us.
Thank you, Tracy. Thanks for putting on this event. I appreciate it.
Yes. Have a good day.